Hey guys, so I made a post the other day talking about rebuilding your high pressure fuel pump, and it seems to have grabbed a lot of people's attention. So I sort of wanted to make a video because a post would have ended up being too long and too much reading for more people to care about. So here I am making a video because there's a lot of different things that I wanted to sort of discuss and talk about with this and sharing some of my experiences and sort of my expertise, if you will. And I'm kind of going off this off the top of my head. It's not like scripted. I'm not some influencer or, person who typically makes YouTube content or anything like that. So excuse my presentation. I guess I'll start off by saying first and foremost, I kind of want to get it out in the open. Like, to be frank, this isn't something that I consider to be very do it yourself friendly. And I was pretty naive going into it myself, thinking that it would be a lot simpler than it was. There's a lot of stuff you can fuck up, or if you don't fuck anything up, you just kind of waste your time. And there's like a lot of specialized, like not specialized, but like things that people typically wouldn't just happen to have on hand. I don't think most people have ultrasonic cleaners or vacuum degassing chambers or vacuum pumps. Like, most people don't happen to have those things. And if you were to buy that equipment, then you're into it about as much as I would charge you to rebuild it in the first place. And then there's still the chance that you fuck it up because there's a lot of below the surface level knowledge, and like just a lot of things that experience and trial and error has taught me that you wouldn't otherwise think about. And there's just a lot of thought went into being able to do this. And it's not to say I don't think like no one else in the world could do it or figure it out, but I'm saying most people couldn't. Like, most people don't think like that. So this isn't something that you should really be attempting to do yourself, because you could damage certain components trying to disassemble your pump or reassembling it, not knowing what you're doing or why. And I've actually had a few instances of people who have attempted to rebuild the pumps themselves, and they unknowingly fucked something up and they couldn't get it working. So they ended up sending me the pump, and then I can't do anything with it now because they damaged a piston bellow or something like that. And those hard parts like that aren't just something that you could go on to FCP Euro and buy a replacement for. You have to source another pump. And if you're sourcing another pump, well, then I might as well just rebuild that pump and keep everything matched with the pump that it came out of. It doesn't make a lot of sense unless I happen to have a spare part from another pump, which typically doesn't happen. But like I said, it's something that you shouldn't you shouldn't really be attempting yourself, because there's just a lot of nuance to it that you could easily mess something up. And even if I shared like step A to step Z, how to do it, what you need, there's still the experience and the sort of finesse that hands-on experience doing multiple pumps teaches you that you don't have diving into it the first time. So it's definitely more, I would say, more above the novice level, like do it yourself, even if you had all this stuff. And I don't want to sound like greedy or anything about it, but when I don't really want to share that knowledge at the same time, because coming from my point of view, I started doing this in the BMW world, And when I first started doing it, I was seeing other people were having limited success, short-lived success doing it. And I thought, maybe this is something that I could figure out what it is they're doing wrong, and then share this knowledge for, you know, everyone, you know, to do themselves, thinking that this would be something that you could spend your day off or whatever to do it yourself, and that would be that. I didn't think that I would ever end up turning this into a business or anything like that. So sort of what happened with the BMW side of things is I shared my progress along the way, like along the journey of doing it. And as a result, what happened was I came to a point where I saw this doesn't make sense for most people to do. So I think the next best thing that I could do is offer a service to do it, and I would be offering a pump that's more reliable than the factory pump, because I'm addressing the weak links that do make the pumps inherently unreliable, and I could do it for a fraction of the cost as what it would cost to buy a new pump. And I kind of came to a point where I was confident enough to stand behind it with a warranty, because it's like, if I'm confident enough to do that, like, I don't want to deal with it twice. So if I don't think that it's not going to come back, I'm not really inclined to offer a warranty. But if I'm confident that I'm never going to have to deal with it again, then I'm confident enough to stand behind it and offer a warranty. So sort of what happened was there were people that sort of took some of the breakthroughs that I was sharing and decided to capitalize on it for themselves. And the problem was that the information was still incomplete from everything that I know in my head how to do it. They didn't have all the pieces of the puzzle, because I never made one comprehensive video just laying everything out. It was more just snippets and bits of my progression. They were copying or trying to copy what I was doing without understanding what, how, why, why this does that, why this fails, how this works, what happens if you do this, what happens if you do that, etc., etc. So, people were trying to copy that, and it kind of just wasn't really fair to me at that point, because even though I did start off with the intention, originally thinking that it was going to be something that anyone could do, it turned into not that, and then people essentially just stealing all of the trial and error, and frankly, the the emotional distress of figuring it out, having something fail multiple times, and the determination to keep trying different things. And it took a lot of resilience and perseverance to keep pushing through, but eventually I got there. So I don't want to be too, I'm not going to be offering kits to do it yourself. I'm not going to be offering pointers how to do it. I am going to be strictly sticking to offering a service, because again, it's not viable for anyone to do. It doesn't financially make sense for anyone to do it themselves. It doesn't make sense for me to share that knowledge, because other people would just steal that and then basically be in direct competition with me. And, if someone wants to go through all of the pain and anguish to figure it out themselves, and start their own service, then so be it. I can't stop that, but I don't think just anyone could do that. I think that it takes a certain mindset, and happening to have a certain background, in different topics, because let's be fair, the people who designed this pump, it wasn't one guy, it was a team of engineers, and I'm one guy that reverse engineered everything essentially to figure this out. So like sort of multiple different respective fields. So it's a lot to know. To sort of give you some examples of that would be like, I sent out a sample of the OE fluid to an oil analysis lab, had them determine what type of fluid they were using, consulted with oil tribologists, to discuss why, what kind of conditions and environment that it would be subjected to, like, the temperatures and the type of metals and the type of seals that we're dealing with, basically to determine what would be a good, base, and then the additives that I would be looking for in that base for things like anti-cavitation, anti-foaming, anti-wear, shear strength, etc., etc. To sort of give you another example of that, the material of O-rings that I ended up going with, and what the factory is using, and why I think they went with that. Basically, the factory went with, between Bosch, BMW, Bosch was the one who designed the pump. VDO, Continental manufacture it, but I digress. Between BMW, Porsche, Mini, whoever, if it's a Bosch designed pump, they're essentially all using Teflon coated nitrile butyl rubber O-rings, and the problem with those is over time, over the course of its life, it's subjected to a big window of heat where you get thermal expansion and contraction, and then basically you have the O-ring going like this as it heats up and cools down so many times, and what happens is the Teflon coating starts to break off, and when that happens, then the fuel can come into the fuel comes into contact with the O-ring, the nitrile rubber underneath. It breaks down the rubber, and then allows for fuel to contaminate the hydraulic fluid, which causes a cascade of other failures until the pump no longer functions. So there's that, and there's like, one of the bigger breakthroughs that I came up with was the vacuum degassing that was aimed at solving the cavitation problem that I was running into. Cavitation is essentially micro implosions that happen at the surface of a metal, and that happens because you have those piston bellows and they're expanding and contracting so fast, like to basically build the pressure in the pump. And between those little wafers, they're expanding and contracting, and it causes implosions, which take away a little bit of metal every time, like sort of like TNT eroding a mountain to carve a road through it, but on a microscopic scale. So it thins the metal out until it fatigues and breaks, and then the pump can fail that way. I was running into the pumps failing that way before I came up with the idea to try to vacuum degas them. And like once I did that, I realized there's really two main benefits to it. Is the anti-cavitation, for one, that's the longevity, and then the performance of it, because if you really understand how the pumps work, they rely on hydraulics to build their pressure. So in any kind of hydraulic system, like, take hydraulic brakes or hydraulic clutch, for example, if you have any air in there, your pedal is going to be really spongy, and because you can compress that air, right? So if it's bad enough, if there's too much air, it's not going to work at all. And that's the second main reason why the pumps fail, is because they'll either lose too much fluid to the point where they start getting air ingressing through the shaft seal, or they just, you know, get too low on fluid and can't like, you know, the performance is degraded. So you want to get all of the air out of it to be able to maintain the maximum performance of the pump. And those are really the two main reasons that the pumps fail. I have my beliefs why they went with the nitrile rubber O-ring or the Teflon coated O-rings. I don't necessarily have like leaked internal documentation discussing it, but I do have evidence that's pretty indicative, and there's a good motive why they would want to do something like that. And basically, what I believe they did was they engineered the pump to fail. And why would you want to do that? Because you make more money if you build something that you have to buy again and again and again. And like, to sort of get around it a little bit, like when you buy cars new, they come with a warranty, right? So they don't want to be replacing these pumps like willy-nilly, during the warranty period. So they have to be able to engineer them to outlive that warranty but not fail before. Well, how do you do that reliably? Well, you take out all of the unpredictability variables out of it by designing something that's very reliable. You take a proven design like these swash plate style pumps, which are commonly used in aerospace and aviation without problems, going thousands and thousands of hours between service, and you sabotage one or two things like the O-ring material and the shaft seal material. And with that, there's a science behind taking like a certain material O-ring, and you can say, okay, this is the environment and conditions that it's going to be subjected to, and we can sort of predict how long it will last in those conditions and that environment. And they'll pick something that sort of overshoots their target for how long they want it to last. And the cost of those O-rings, they're more expensive than the FKM O-rings that I'm using. So it wasn't like a cost cutting measure that they cheaped out on the O-rings. They actually spent more money across all of those O-rings to be able to pick that, but it's just not the best material for the job. Teflon coated O-rings like that would be better at something that has more of a consistent pressure. Maybe chemicals, but like I think of like hot steam applications. That's where, or like food grade stuff. That's where I would pick a Teflon coated O-ring for. But FKM is much better at chemicals, petroleum, ethanol, all these additives that they put in fuel, like Techron, which is essentially a PEA, I think that stands for polyetheramine. It's like a cleaning agent that does a really good job at cleaning deposits off your intake valves for indirect injection and keeping your combustion chamber clean. Just different chemicals like that. It's not as good, and the FKM is just really a better choice for the chemicals and then the window of temperatures that the pump operates in. So that's one of the, that's those O-rings and getting too low on fluid are essentially the two reasons why they fail. And there's a bunch of other little tweaks that I kind of do, like second line of defense type things for less common failures that I've seen, to basically try to offer the most reliable pump possible within my means, because I'm one guy essentially working out of my garage. I don't have an unlimited budget. I don't have a team of engineers working behind me to make this happen, but I've gotten a lot further than granted anyone else that I know of, to be able to even offer a service doing this in the first place. Another thing I kind of want to say is about the design of the pumps. Like I was saying before, Bosch designed them, VDO and Continental manufacture them. They're manufacturing them for Porsche, Mini, BMW. It's the same pump, just in a different body, a different configuration, like a different footprint to be able to fit, what it needs to fit. But internally, the components, like there's several components that literally will interchange, like the piston bellows, the piston caps, the plungers, the plunger caps, the springs, the fuel control solenoid, the diaphragm, all of that stuff. Like I could literally take out of a BMW pump and put inside of a Porsche pump, and it's the same thing. So, and because the pumps kind of fundamentally work the same way, my process from the BMW pumps, like all my experience, my knowledge, everything directly translates over to the Porsche pumps. And I don't know if I said it before, but it's to be determined if I can do the plunger style cam driven pumps. I would need someone to send me one. I don't know if it's viable. It At least for the BMW side of things, it wouldn't be cost effective because they're cheap enough, and there's a lot of aftermarket performance solutions. So most people just don't. Just wouldn't be worth it. But again, you guys got the Porsche tax, so it might be something worth looking into. I'd need to get my hands on one. And it's not something that I'm gonna necessarily go out of my way right now to try and figure out. But if someone wanted to send me a dead one, like I'll take a look at it. But yeah, there's just a lot of nuances. Like understanding like the role of the accumulator, how to set the preload correctly, why I came to that conclusion. Just a lot of thought and knowledge and effort went behind this. So yeah, I mean, I guess I'm pretty excited that I just happened to stumble upon that one post of that guy that took apart his pump, and like I saw the picture, I was like, holy shit, like looking at all those parts, like that's the same fucking pump as a BMW pump. So this is a whole nother market for me, and potentially a more lucrative market, because you guys get shafted for $2,400 pumps, like, and the BMW side of it, they're like $1,400, and it's a little bit harder of a sale. People tend to just go for like a used pump, and you're taking a gamble on it. It might last you a long time. It might fail right away like it did for me, but the point is that there's people selling used pumps and stuff, and that platform tends to be filled with kind of just cheap asses. Like they're a really good bang for the buck platform. You can put a little bit of money into it and make good power and have a pretty quick car for not a lot of money. So people on that platform, they don't want to pay a lot of money. Even $500, what I charge, is kind of on the high side. And I understand there's also the uncertainty of it, but and in the 15,000 something dollars worth of pumps that I have rebuilt so far, all those guys seem to be happy with it. And I don't give a shit if you beat on it. Like, I don't give a shit if you expose it to 100% ethanol. Like, try and break the fucker. I would love for people to shake down the weak links so I can continue to improve upon that, and not only have something better for myself, but have something better for you guys. That's kind of all I can think off the top of my head for now anyway. So I just kind of wanted to talk about that with you guys, and say what I had to say about it.